Alright people, so welcome to Jumbo IAS and welcome to UPSC Prelims Phoenix batch. In this batch, we revise the entire syllabus for UPSC Prelims examination. Now that includes both the static portion as well as current affairs. Now this particular lecture which you're actually watching is related to our current affairs lecture series. And those of you who have already joined our Phoenix batch, well, you all know this, that currently in the current affairs lecture series, we are covering science and technology related current affairs. Okay, and today is day 4 for science and technology related current affairs, and in day 4 your daily targets are space technology. Now you see, we'll cover space technology in two parts, okay, because it's a hefty topic. Now in the first part, which is today's lecture, we'll cover space technology and all the India related missions, ISRO related missions. Okay, in the next part, in the space technology part 2, we'll cover all the astrophysics, astronomy, black holes, gravitational waves, all the scientific things. Okay, all right. Now, the notes for today's lecture were given to you well in advance, one day in advance. So I'm hoping that you have revised, gone through the notes before watching this lecture, because that is really important. Okay, first step needs to be completed, then only you can move on to the second step of watching this lecture. Now, let's revise those topics, those current affairs related to space technology again through a set of 20 MCQs in this lecture. Okay, so let's begin. So science and technology, current affairs, day 4, and today's targets are space technology. And well, it will be covered in two parts. So Indian missions. All right. So let's begin with question number 1. Okay then. With reference to Gaganyaan mission, consider the following statements. The mission aims to send a 3-member crew to geostationary orbit for a duration of 3 days. The human-rated LVM-3, the rocket, features a 2-stage propulsion system consisting of solid and cryogenic stages. As of April 2026, the mission has successfully completed airdrop test of Gaganyaan-1 crew module using a Chinook helicopter. Okay, so Gaganyaan mission would be India's first mission through which we'll send astronauts on our own for the first time in space. Okay, now the Gaganyaan is the spacecraft in which we'll send our astronauts. We'll be sending 3-member crew, 3 astronauts, and we'll be sending these 3 astronauts in low Earth orbit, which is around 300 to 400 kilometers altitude. At this altitude, we won't be sending them to geostationary orbit, which is at a height of 36,000 kilometers. Okay, that is not what we are doing. We are sending astronauts at this height. And it's the height at which astronauts usually go. The International Space Station, through which NASA's astronauts, Russia's astronauts, European Space Agency's astronauts, well, they go to International Space Station, and this is also at this height only, low Earth orbit. So first statement is false. Now, the rocket that we are going to use to carry Gaganyaan spacecraft will be LVM-3, ISRO's heaviest rocket, okay, and the human-rated version, which is capable of carrying humans to space. Now, this rocket features 3-stage propulsion system. First is solid, then liquid, and then cryogenic. Cryogenic means the fuel is kept at extremely cold temperatures. So it's a 3-stage rocket, not a 2-stage rocket. So this is also false. Now, as of April 2026, the mission has successfully completed the airdrop test. You see, we are sending astronauts to the space. We have to bring them back also. Now, how will they be brought back? Well, when the astronauts would be coming back to Earth, they would be dropped in the Bay of Bengal. Okay, this is known as the splashdown. Now, so that this process is efficient, proper, with all the safety measures, we are conducting certain experiments to see whether this is possible or not. Now, the experiment is called airdrop test, which was successfully completed, which means that astronauts can be safely brought back to Earth. ISRO has validated that through an experiment called the airdrop test. And in that, we basically dropped the crew module in which the astronauts would be housed from Chinook helicopter. So this part is absolutely correct. The answer would come out to be 3 only, B. Right? Next. In the context of Gaganyaan orbital module, what is the primary function of service module? Okay. Now listen to me very carefully. The astronauts would be sent to space in low Earth orbit. Right? Now, Gaganyaan spacecraft would orbit around the Earth, okay, for 3 days, and then it will bring astronauts back to Earth. Now, this Gaganyaan spacecraft consists of 2 modules. One is the crew module, in which the astronauts would be there, and then is the service module. The crew module, well, astronauts would be stationed inside there, and service module provides the energy to crew module, all the essential things that are required by the crew module, like propulsion. It should be able to move, energy, thermal heating or temperature control. All of this would be provided by the service module. Okay, so service module is C. Clear? Next. Regarding Aditya L1 mission, consider the following statements. It is India's solar mission. It has already been launched. It is placed in a halo orbit around Lagrangian point 1, which is approximately 1% of Sun-Earth distance. The VELC payload is designed to study solar photosphere and chromosphere in near ultraviolet. The mission provides real-time monitoring of coronal mass ejections to improve space weather forecasting. Now, the thing is that this Aditya L1 mission is there. It is India's solar mission to study the sun. Okay, Aditya in Sanskrit means sun. Clear? Now it is placed at L1 point, Lagrangian point 1. Now what is Lagrangian point? Now there are 5 Lagrangian points between Earth and Sun. Lagrangian points are those geometric points at which the forces balance each other out. The gravitational forces of Sun, Earth, and the centrifugal forces. All right. Now, this is Sun, this is Earth. Okay, there are 5 Lagrangian points. This is Lagrangian point 1, this is Lagrangian point 2, then there is Lagrangian point 3, then there is 4 and 5, diametrically opposite over here. Okay, these are these Lagrangian points at which forces balance each other out. Now your Aditya L1 mission is placed here, right between Earth and Sun, for obvious reasons, because its job is to observe the sun. So why would it be placed over here or here or here? It wants to be placed directly in line. It should be placed directly in line of Earth and Sun so that it can observe sun continuously. Clear? This is L1. At this point L2, well, James Webb Space Telescope is placed, but that's a different topic altogether. Okay, we are focused on L1. So it is placed in a halo orbit around Lagrangian point 1, which is approximately 1% of Sun-Earth distance. Absolutely correct. Clear? Now to measure or to study the sun, there are various instruments on this spacecraft L1. Okay, there are many instruments. One such instrument is VELC, visible just a second, VELC, visible emissions, some coronagraph. Okay, VELC and SOOT. Sorry, not S. Visible emission line coronagraph. So VELC is there to measure solar corona. Then there is SOOT, solar ultraviolet image telescope. Okay, now what is corona, what is SOOT doing? For that you need to understand sun's layers. Okay, so sun is basically divided into various layers. The innermost is the core of the sun, where actually the energy is produced through nuclear fusion. It is around millions of degrees Celsius. Then there is radiative zone. Then there is convective zone. Then there is photosphere, the outer layer of sun which is visible to us. Then there is chromosphere. Well, it is a magnetic layer over photosphere. And the outermost layer, the solar rays, whenever we draw sun, we show these rays, right? Well, these rays are sun's corona. It is made up of plasma. Clear? Now, the weird thing about this is that, well, photosphere is around 6,000 degrees Celsius and core is around millions of degrees Celsius, right? Naturally so. As you move outside sun, well, it becomes cooler. But then corona is again millions of degrees Celsius. Now, why is that? Okay, this is what we are going to study through VELC. So VELC is to study only corona. That's why C stands for coronagraph. Okay. Whereas the job of SOOT, ultraviolet imaging telescope, it is to observe photosphere and chromosphere. Now let's get back to this question. VELC payload is designed to study photosphere and chromosphere near ultraviolet. No, that is the job of SOOT, as the name suggests, ultraviolet imaging. VELC is for corona. Mission provides real-time monitoring of coronal mass ejections. So plasma is spit out by corona. Okay, and these solar flares or these highly charged particles are released into the space. They sometimes even come to the Earth and disrupt satellite communication. Okay, so we are going to study coronal mass ejections for better weather forecasting in the space. Okay, so this part is correct. The answer is C. Clear? Next. Coronal heating problem, which Aditya L1 aims to investigate, refers to which of the following, which I just mentioned. That photosphere is cooler than outermost layer of the sun, which is corona. Why sun's outer atmosphere is significantly hotter than its surface? The surface is photosphere, but its atmosphere, which is made up of corona, is hotter than the surface of sun. So this weird thing is called coronal heating problem. Why the atmosphere is hotter than the surface? So we'll study this. Okay, next. With reference to Bharatiya docking system, what does the term androgynous design signify? Now look, what is Bharatiya docking system? Well, two spacecrafts can dock with each other. They can, so for example, there is a spacecraft in space and another spacecraft would come and dock with it. Okay, this is Bharatiya docking system. Now in this, androgynous design is being designed by ISRO. You see, when you put switch in a socket, there is switch and then there is a socket. They are designed in a specific way that this fits properly, right? Now in androgynous design, well, the spacecrafts would have similar sockets so that they interlock with each other. So this can be stationary and this would come and join with it. This can be stationary and this would come and join with it. Okay, so both of them can join with each other. Same socket. Okay, no plug and socket, same thing. So docking ports on both meeting spacecraft are identical and interchangeable. This is the point. Now, Bharatiya docking space system is part of ISRO's SpaceX mission. Okay, next. Just remember this. The answer to this question is B though. Next. Consider the following pairs regarding SpaceX mission. So it has three versions. SpaceX 1 successfully completed hard docking of 2 satellites in January. Yes, with androgynous design. This was completed. Now SpaceX 2 and 3 are left. Focused on docking in highly elliptical orbit for lunar sample return. So earlier, 2 satellites in same orbit would dock with each other, join. Now, if we are launching another Chandrayaan 4, in Chandrayaan 4, what will happen? A lander would go there, collect some samples and bring them back to Earth. Now, for that to happen, well, you'll keep one spacecraft in orbit of Moon and one spacecraft would go to the ground, pick up samples and then lift off in highly elliptical orbit and then come back and combine with this, and then this will go back to Earth. Okay. Now, whenever you have to lift off from Moon, you have to be in a highly elliptical orbit. So you need to basically master 2 satellites or 2 spacecrafts in highly elliptical orbit combining with each other. This is SpaceX 2 for Chandrayaan 4 mission. And this is for Bharatiya Antariksh Station, that India will establish a space station and a spacecraft can go and dock there. SpaceX 3. So all are correctly matched. Okay. Next. Regarding Navik, navigation with Indian constellation. This is India's own GPS. Okay. It provides regional coverage of India and an area extending up to 5,000 kilometers beyond its borders. As of April 2026, the system faces a 3D fix challenge due to having fewer than 4 fully capable satellites. The new NVS series satellites incorporate indigenous atomic clocks developed by SAC Ahmedabad. Now you look, now you see, GPS or these satellite services which provide navigation. GPS is very important. All your Swiggy, Uber, all these use GPS for navigation and timing also, that you will reach by 13 minutes, 20 minutes. That requires timing. Okay. Now India has created its own system because these things are used in Well, defense also. A missile needs navigation to hit its target, and Navik was used in Operation Sindoor as well. Now, Navik GPS provides global coverage. Anywhere you are in the world, GPS can provide you navigation. But Navik provides navigation in India and 1500 kilometers beyond India's border. So basically, South Asia, SARC. So it's not 5000, it's 1500. Okay. Now, for Navik, we had launched 7 satellites for proper navigation. Now, out of these 7 satellites, less than 4 are operational because some faults came out. Okay. Now, because less than 4 are operational, because of this, we can provide navigation in 2D. So, if you're moving on a road, we can provide good latitude, longitude, time also. But at what altitude you are, this is useful in aircrafts and missiles. That can't be provided because less than 4 satellites are operational. This is known as 3D fixed problem. We can provide 2D navigation, not 3D. So yes, this is correct. That is why we are replacing all these satellites with a new series of satellites, which will have indigenous atomic clocks. Atomic clocks for timing. If you're moving at 800 km per hour, missile is moving at 100 km per hour, the satellites would be able to tell that it will reach in 10 seconds. You understand? So atomic clocks would be developed by India only. So this is absolutely correct. The answer would be D. Okay. Next.